All right, guys, the doors are closed. This is sort of loud. Let's get started. I assume everybody can hear me. Okay. First of all, I'm going to show you how to build your Kubernetes monitoring system. So you start with data. Can be anything, application, infrastructure, system process, just all of your data. You pipe it into a big honking data engine. And then you just get unicorn and rainbow dashboards. That's simple. Many people that get involved with Kubernetes or any modern infrastructure very often make this assumption. It turns out sometimes the unicorns don't really show up as expected. So that's what we're going to talk about today. My name is Degioanni. I'm CEO and founder of Sysdig. I'm also the original creator of the Sysdig open source project. Today we're going to talk about monitoring Kubernetes. The title of my session is You're Doing It Wrong. I'm trying more to think about how things are changing, propose best practices, give some ideas, and also show a couple of things that we've been working on. I'm going to do this by using the tools that my team works on. So open source Sysdig, which is a command line single machine monitoring and troubleshooting tool. It's open source. You find it on GitHub at that link. And then I'm also going to use Sysdig Cloud, which is our distributed monitoring tool with heavy focus on Kubernetes. What I want to point out is that I'm using these tools because these are the ones that I work with every day, so I'm comfortable with, but the content of this presentation will try to be vendor neutral and focus more on like best practices than on the usage of a specific tool. All right, let's start with a bit of context and a bit of where we're coming from. So the keynote this morning sort of created a good timeline of how things are moving, and we're definitely in the middle of something quite revolutionary here. So I'm putting three things here, PC and servers, virtual machines, and containers. And what's interesting to me is that this time many things are changing quite dramatically. In particular, the unit in the server era was the machine. The unit in the virtual machine era was still essentially the machine, a virtualized version of the machine, but you were still working with a complete host that had a complete operating system. Now the unit is the service, the component of your application, and what you're orchestrating are just little pieces of an application, not machines anymore. Orchestration was none for servers. Orchestration for virtual machines was essentially a piece that you were bolted on, and in fact that's one of the reasons why we don't have a standard for that, while orchestration now with containers is native essentially. That's why we're here, because the two things are evolving together. And of course, we're going from monolithic infrastructures to service-based infrastructures. This means, of course, that things are becoming more complicated for many reasons. They are becoming much better, of course, but they are also becoming more complex. In particular, this beautiful slide is my artistic representation of a three-tier application with a cache and the web server and the database. And this is how we were used to think about our applications. And now we have more something like this, where we have services that are orchestrated. So each of the gray boxes here is essentially a node, a machine, physical or virtual, and the application components move around on these machines to implement services essentially. And not only they are orchestrated in arbitrary places, but they're often moved to a different place. So you end up with something that can be overwhelming, especially if you want to understand what's happening, if you want to monitor it, and if you don't adapt to this new way. The thing that is especially exciting for me, however, is how revolutionary a tool like Kubernetes can be not only from the technical point of view. Yeah, we're used to think about, load balancers and web servers and databases and replication controllers and pet sets and all of this kind of stuff. And of course, the technical side is very exciting and it's a progress. But this is the first time in which we really design tools that are created to reflect the team organization, right? So the primitives in Kubernetes match very well to how people work together and how we want to evolve our software in a way that is more decoupled, more distributed, and more people-based. So how do all of these things impact monitoring and monitoring our infrastructures? I'm going to focus on 4 things that I believe are becoming harder nowadays. Number 1 is getting the data. Definitely harder now with all of these moving parts and also with the opaqueness of containers. Number 2, making sense of the data. Number 3, troubleshooting. So what do we do when something is going wrong to understand the root cause? And number 4, people. So starting with getting the data, what makes container great? They're simple, they're small, they're isolated, they contain only the dependencies they really need. So what I was saying before, we started by considering containers sort of lightweight operating systems that could be started faster than a full virtual machine. Well, in practice, they're not. In practice, we want to keep them as small as possible. We want to keep them as simple as possible because we want to be able to download them quickly, start them quickly, move them quickly. So, and also, keeping them simple has a bunch of benefits that we are all aware of. Only problem, keeping them simple also tends to make things a bit more opaque. So, typically, there are 2 approaches that I'm going to describe for getting insights and extracting metrics or doing troubleshooting inside containers. The first one is pods. So this is a primitive that Kubernetes is designed exactly for this. So essentially, you have, for example, you have two containers running on top of the same machine. What you do is you wrap them, you put them inside the pod, and then the pod can contain other containers, and in particular you can have monitoring containers that run in the same place and are essentially able to live in the same namespace or in a somewhat similar namespace. Another way, which is the one we use in Sysdig, is based on instrumenting underneath the containers. So containers at this point are just left where they are, and what happens is there's a component in the operating system, a kernel module, that sits underneath these containers, captures the data, and by hooking a couple of places at the kernel level, in particular, for example, the system call enter and exit interface in the kernel, this means that the red circles are able to capture stuff like storage, inter-process communication, network activity, resource usage, but essentially everything that each of the containers does when it talks to the operating system. At that point, there's one container, which is the Sysdig container, which is in charge of collecting this information and doing stuff with it. I will show you a couple of demos in the later part of my presentation. The disadvantage of an approach like this is, of course, you need to deploy something inside the kernel of the operating system. On the other hand, the benefits are that you see everything. You see containers. You also see applications. So you have something that is horizontal. Very often something happens outside your pods, and you want to be aware of that. And the other thing is you only have essentially one piece to deploy, instead of essentially having to add another container for inside each of your pods just to extract the metrics. The best approach here probably depends on the specific use case, but in a general way, it's important to make sure that the act of instrumenting your infrastructure is as transparent as possible. So for example, in the case of Sysdig, what you do is you run the Sysdig container on the machine. The Sysdig container takes care of instrumenting the operating system kernel, and then takes care of starting extracting this information and collecting it. And this brings me to some guidelines, and talking about stuff that very often people do wrong. And by the way, probably if there's something that you want to bring home from my presentation, this slide is the most important one. So you should not be involved in instrumenting for monitoring. So I was showing you, the approach that we have at Sysdig. That works by essentially having a daemon set and making sure that one of these containers runs in your infrastructure, and that's it. So in a general way, there are ways, and Kubernetes can help us making deployment of monitoring really transparent, and making configuration maybe not completely unnecessary, but at least the bare minimum. In particular, ideally, you should not be involved in producing anything that is not a custom metric. What I mean is everything else, infrastructure, basic metrics like CPU, memory, and disk, application metrics, database metrics, response times, all of this kind of stuff can be collected automatically and should be collected automatically. It's not only nice to have, because, of course, the less work you do, the better. But nowadays it's a must-have, because in a heavily instrumented infrastructure and heavily orchestrated infrastructure, there's just no time to go and worry about extracting metrics. So the only metrics that you should pipe out are the ones that you produce manually, which should be hopefully a limited set, because a bunch of stuff is already collected for you. The other thing is every single metric should be tagged. This is very important, because there's no way to make a sense of this stuff unless you have proper tagging that reflects the logical organization of your infrastructure. Let me show you what I mean for a second. So here I'm in Sysdig Cloud, and I'm just selecting one of the namespaces, and now I'm charting a metric which is the request time, essentially the response time for this service. So essentially this is the average for the whole namespace. But what I want to do is I want to be able to go and tag these, for example, by, replica set. And at this point, I'm able, in this namespace, to see that the different response times for the different replica sets that I'm running. Or maybe I want to do it by something like pod.name. And here I'm seeing essentially how the response times of the different pods in this infrastructure compare to each other. Maybe I want to do it by image, container image. And here I'm seeing how the different images compare to each other in terms of response time. Or maybe I even want to go to the granularity of the process. So this ability to segment stuff, first of all, needs to reflect how Kubernetes organizes things. So what's happening here? The metric is collected from any container. These containers move around in your infrastructure, but all of these containers have tags. Some tags are explicit because you give them to your containers, and some tags are implicit because they can be essentially collected from Kubernetes. All of these is put together, and then this metric is aggregated in different ways depending on the aggregation that you do. Tagging is critical. It's what really makes a difference in a modern monitoring tool. Tagging must be integrated with Kubernetes, so any tool that doesn't talk natively to Kubernetes to extract the tags is not a good tool. By the way, there's quite a bit of work from both vendors and community to make this work very well. Again, I showed you an example with Sysdig Cloud, but just make sure that your tool does that. The other thing that is very important is you should not be involved with tagging. exactly like you shouldn't be worried about collecting the metrics. The same way the metrics should come. You should even when you meet your custom metrics, you should just meet the metric, and the tool should be absolutely totally capable of enriching your metric with all of these relevant tools. Because first of all, tagging the metrics is not straightforward because it requires you to have a context of where you are when you're emitting the metrics, so it requires you to keep state, and that's bad. And second of all, you can forget or you can do it wrong, and you don't want your data to be wrong just because you didn't know that you were supposed to tag or you didn't do it right. So again, and the last thing is make sure to collect everything. Another thing that I very often see people do is pre-filter the data before it goes into the washing machine. So in the data engine, and that's appealing because essentially it of course decreases a lot the amount of information that you need to send to your data engine. By the way, every time you tag a metric, you essentially make a duplicate of that metric, right? So if metrics are tagged by default and you have like tens of tags for each of the metrics, essentially you need tens of the storage and tens of the responsiveness 10 times the responsiveness in your monitoring tool. So it's not trivial, but on the other hand, the problem is the more complex these infrastructures become, and the more having all of the data is very important. So you want to be able to do this kind of stuff interactively, like I showed you, and not decide a priori what kind of segmentation or what kind of dashboards or what kind of data you're going to export. All of the data should come with all of the tags, and then you can use it after the fact. Which brings me to troubleshooting. So another thing that is becoming more challenging is, I'm seeing the trend of my key performance indicators, I'm receiving alerts, I know there's something wrong. Now what? Now it's not trivial because, again, containers are opaque and they make troubleshooting even harder than metric collection. In particular, containers are designed to be small, so all of the tools that we were used to rely on, you SSH into the machine, you do an strace, you do a PS, you do a top, you do whatever, if config. All of that, very, very likely, you're not going to have it, and it's going to be complicated, essentially, to go and understand how things work. So let's go in a shell for a moment, and I'm going to run our open source tool, Sysdig, on a local Kubernetes infrastructure that is running on my laptop. So I'm looking at, essentially, as you can see, it's very similar to HTOP. By the way, we showed this already at last year's conference, but it's always fun to show it, so bear with me if you've already seen this. But essentially, Sysdig is designed as your, let's say, Wireshark for your host. So you're able to go and get very granular information, and you're able to drill down, and you're able to capture this information and maybe saving it to file. So now I'm looking at essentially at something that looks a lot like top or HTOP, and the process is running on my machine. But one difference between these and top is that I can click on F2, and I have a list of views. And for example, I can look at the list of containers running on this machine, and I'm able to select the container and click enter, and now essentially I'm inside that container and I'm able to see what's happening inside the container. So that makes use of the same technology, a kernel module underneath the containers that I showed you in the previous slide. What's interesting here is, as you can see, I'm executing this command with a parameter that points it to my local Kubernetes master, which means that not only I'm seeing container information, but I have views like, for example, Kubernetes deployments that show me the deployments that are running on the machine. So what happens? The data is collecting from the kernel. There's a lot of stuff, I/O, disk, CPU, memory usage, and this kind of stuff. It's correlated with the metadata coming from the master, and at this point I can see something like that. The other thing is I can save this information to file, exactly the same way I do with Wireshark. At this point, I'm opening a file that I saved like a couple of hours ago from my machine, from the same infrastructure. And so, I can give this file to anybody, and I can use this file for exploration. So again, let's go to Kubernetes services, and we can see, for example, that there's a Java application. Let's drill down into it by clicking enter, and we can see that there are 3 pods on these inside this specific service. We can click on one, and now we're seeing the containers. There's only one container in this pod. Let's keep going. Now we're seeing the processes inside that container, and we're seeing, nginx, a couple of scripts. So let's go inside the nginx worker, and now I'm inside the process. So from the context of a Kubernetes service, I was able to drill down in multiple steps, and now I'm inside one of the processes that is running inside one of the containers. And now that I'm here, I can, for example, look at the files that have been accessed by the process. In this case, just a log file. By the way, I can drill down even further. By clicking on the 5, I'm seeing the specific data that is being written on that file. Or I can look at the connections, and I can see the different connections that this container has established. And again, I can select a specific connection, and I'm seeing the data, including the HTTP requests and responses that are generated on this specific connection. But I can go even further and click on dig, which is F6, and now I'm seeing the specific, just for that connection, the specific actions that this process did. So I can see the accept, I can see the receive from, and the write on the sockets with the data. I can see that the socket was shut down in the middle, but then some data was still received by the socket, and then I can see the close. So we went from essentially the old data on the machine, drilling down and narrowing down to a specific connection through essentially a user interface that is oriented toward this use case. So again, this is a complete open source tool. It's totally fun to use. There's the link on my slides. I think it's something that can really be beneficial for troubleshooting containers, which is something that we very often oversee. Last thing that I want to talk about is people. So, as I told you before, I'm very excited about trying to rethink monitoring in a way that is a bit more people-oriented. So microservices are about people. Microservices start by us wanting to make our teams more decoupled and our development teams scale better. So can monitoring reflect it? Today at Sysdig, we are announcing a new feature called Sysdig Teams, which is designed exactly for this. So the way it works is you get all of the data in the way I showed you before. So, application containers, metrics, it all goes in a central database, and this is correlated with Kubernetes service metadata. And then the data is filtered and pushed to different teams based essentially on not only the physical topology, but the Kubernetes metadata. So this is designed to reflect people organization. It's heavily integrated with Kubernetes. I'm going to show you a little demo in a second. It supports isolation and customization. So if you are part of a team that is monitoring a specific service, you will only see the data for that service, and the data will be filtered even if those containers or pods run on machines that are shared with other people. It's completely self-service, and it's centralized. What does it mean? Let's go back here. Can you read this? All right, so this is a deployment. I'm running a local Kubernetes on my virtual machine. So what I'm doing here is just, I'm going to start a service. So this is a deployment. Standard stuff, you can see I will have 3 containers. It's WordPress, I'm using the WordPress image. But there's something different here. There's an annotation section, and as you can see, there's some context here. So first of all, who are the team members for this deployment? So I have essentially 3 email addresses. Then I want a couple of dashboards. This is, WordPress service is talking to MySQL, so I would like the service overview dashboard, and I would like the MySQL dashboard. Then I would like to get my alerts in 2 different ways. One is a couple of people should receive an email when an alert is fired, and I would also like to have an alert posted on a Slack channel. And then I'm configuring a couple of alerts. This is a tiny bit more complex in syntax, but I have a slow response time for the whole service, which is based on a metric which is net request time. And the other one is high pod CPU, and it's essentially an alert on CPU threshold over 80% segmented by pod, so that I have this alert applied to any pod. Now, I'm going to do probably the silliest thing that somebody would do on a stage, because I'm actually starting this service, and I'm expected to receive an email, which sometimes it works, sometimes it doesn't. There you go. Wow, it worked. Thank you, Gmail. So the service starts. Sysdig Cloud talks to the Kubernetes Watch API, detects that the service is starting, reads the annotation, understands that this service is annotated as a team, creates a team for this service, looks who are the users of the team, and sends an email to the users that have not been registered to Sysdig Cloud. So I'm going to activate my user. And now I'm inside, so can I make this a bit bigger? So now I have my own customized monitoring environment that has been dynamically created on the fly for me when the service was created. I can see the 3 containers that are part of the service, and only those 3 containers. Everything else is filtered for me. No matter where those containers go, this will follow them, and everything else, all of the metrics that are not related to these containers, all of the tags, everything else is filtered out so that my environment is isolated. I can, of course, look at these also in a hierarchical way, and I can see, I can see the service, I can see the namespace, and everything else. If I switch to dashboards, I can see my MySQL dashboard, and I can see my service overview dashboard. Again, these are being created. These are already populated with the data. And all of this data, again, is completely collected out of the box. In particular, for example, the SQL queries are collected by looking at the network traffic, by sitting underneath the containers, decoding the queries, and then showing the slow queries. But the point here, these dashboards are essentially now part of this team, and they've been created automatically. I didn't need to log in the monitoring tool to create these dashboards. I just declared which dashboard I wanted when I created the service. So this is what I mean when I say self-service. If I go to alerts, I have my 2 alerts that have been created, and they are already active and looking at the data. But if I go to settings, I can also see that my notification channels have been created, and I have the 2 emails that I specified in the service. These are the guys that will receive the alerts, and I also have the Slack channel, both of which have been essentially configured. So I don't know, we use Slack extensively at Sysdig, and being able to essentially dynamically create a Slack channel that will be tied to a specific service is something that I sort of really love as a concept, and shows a bit the power of this. Of course, a new user has been created, and this user is part of the team deployment prod WordPress, which was created dynamically. But I can always switch to the default theme, and essentially this user has the privileges to also see the full infrastructure. And so now, by just switching the theme here in the user interface, I can go and look at, the full infrastructure, and I can see, my service data, but now I can see every other service's data, and I can see it in a way that is both logical, so namespaces and pods and this kind of stuff, or physical, like machines and containers and so on. Use cases for these, development versus production, so having the ability to segment things maybe at the namespace level, a team per microservice, which is what I showed you before, platform as a service, which is another very strong use case for Kubernetes, tends to match pretty well this kind of use case, because it's possible essentially to have the past teams that start their applications, and magically they also get a link essentially to their monitoring environment for their application, even if their little application lasts only, it's just an experiment. And of course, restricted environments, we talk quite often to people that, for example, work in, I don't know, banking, and you want to have a platform running Kubernetes, but you want strong isolation even from the monitoring point of view, because some containers might contain sensitive information. So in this way, it's possible to clearly isolate the containers because all of the data is filtered out. And that's it. So these are some links. Again, the open source tool, you find it on GitHub or on our website. Sysdig Cloud, this is the website, and we announced it today, so that's a link to the blog post. Thank you for listening. We might have a couple of minutes for questions if anybody has a question. Yes?
Yeah, I was wondering, so your notification system, the system teams have some way to support scheduling those notifications, or would it all flow that to some other app that's in charge of keeping track of that schedule?
Yeah, so with Sysdig Cloud, there's a pretty sophisticated notification set of functionality, so you can, I showed basic stuff, but you can have, PagerDuty, Amazon SNS, you can route them, you can split them, you can do a bunch of stuff essentially. You can have different channels that do different things. So from this point of view, it's like any good modern monitoring tool.
The files that you had there, as I understood, the snapshots of what happened, are they human readable? Are they like in XML? Or?
They are actually in pickup format. So I didn't tell you this about my background, but I was one of the people working on Wireshark for a very long time, and I come from that background. So essentially, when I started designing this, I wanted to save stuff in a file format that would be essentially a standard file format and compatible with other tools. And so we decided to pick essentially the pickup format. So the format per se is binary, and is the same format that can be opened by TCP dump or Wireshark or any other networking tool. But of course, Sysdig is a pretty sophisticated tool, so there are many ways to take this data and convert it to human readable. We even have a Lua integration, so that you can write your scripts in Lua to parse this data and do something interesting for you.
Thank you.
Yes?
So you promised in one slide vendor independence. So what part of this Sysdig infrastructure is now like only cloud-based, or what parts would you say is really something I can use now without this hosted Sysdig cloud?
So, first of all, the whole collection system that I showed you in the slides, that's all open source. So the whole instrumentation is open source, and the whole data collection. The user interface, the command line user interface that I showed you is open source. And then essentially as a company, we build a tool on top of these to collect this data and offering you essentially the dashboards and all of this kind of stuff. That's essentially how we structure this.
All this alerts and annotations, so this looks like as an old definition.
Yeah.
So this is all valid. I can go now on GitHub and like valid, get it running.
So the integration with Kubernetes and the kind of stuff is all on GitHub. The specific Teams functionality that I just showed, well, we just released it, and for the moment it's just on the commercial product. I will get to you.
Assuming that you can use Sysdig on applications that aren't running in a container, is there any advantage to putting that application in a container for monitoring it? Is there additional information you get?
No, it's the same. You get exactly the same information. Well, if it's in a container and it's in a pod and it's running on top of Kubernetes, the benefit is that you get all of the tagging out of the box. So that's the additional benefit, you know, the context that you don't have if you're not running inside the container. Yes?
Do you have any pro tips for using Sysdig to troubleshoot Kubernetes or containers?
A lot. I would say, well, first of all, we have, so a couple of things. One is, feel free to stop by at our booth later, and you know, we can talk to you about that. Go to our blog. We tend to post quite actively, and there's so much stuff that I couldn't show you. Sysdig, the open source Sysdig is really a sophisticated and powerful tool, and we have blog posts that range from you know, advanced use cases to measure latency to fun stuff like running it on an unsecured instance on AWS and waiting for an attack and then observing what the hacker did on the machine. So there's a bunch of stuff Kubernetes related and not Kubernetes related on our blog post. And we're also happy to talk to you if you come to our booth.
Yeah.
Any other question? Thank you very much, guys.